Hello, I'm Stefan Greber, I'm project leader for LXD, and a feature that's actually been showed a number of times on this channel, but hasn't had its own video yet, are LXD projects. So that's what we're going to be looking at today. LXD projects have been first introduced in LXD 3.6, so they've been around a while, and they've been growing quite a bit as far as what they support and how they work. They're effectively a mechanism to isolate a set of instances from the others. This can be used in multi-user environment so that you can have multiple users, each with their own project and not seeing each other's stuff. It can also be used in a single user environment where you want to just separate workloads from a number of different applications. The projects support a number of features that can be enabled based on your preferences, which are effectively what they encapsulate. By default, they will always all encapsulate instances, but they will also, out of the box, come with images, profiles, storage buckets, and storage volumes, all part of the project. Those can be disabled if you don't want them, but by default, that's what's going to happen. The networks can also be tied to projects, but for that, it requires using Oven, which most people don't have, so that feature is not enabled by default. Projects can have limits applied to them, which allows you to restrict things like CPU, disk, number of instances, that kind of stuff. By default, no limits are applied. And you can also apply restrictions, which lets you do things like disable some specific device type on instances, prevent access from specific paths or networks, that kind of stuff. That's particularly useful in a multi-user environment where you want to give access to users you wouldn't trust with full root access on the system, where you can effectively sandbox them to just something that is safe to give to just about anyone. And that's what we use for the LXD multi-user daemon and tooling that I've showed in another video some time ago. As far as accessing a project, well, if you run locally with a normal account, then you should just see all projects and you can just switch between them whichever way you want. That's not ideal for multi-user environment. For those, you can tie a trust token or specific certificate in the trust store to a specific project. So that's pretty useful. It lets you restrict. Actually, you can tie to multiple projects, so you can easily grant access to a specific user to a specific project or set of projects as you wish. If you're a paid Canonical customer, you can also use Canonical RBAC, which then lets you do the same, but centrally through a web UI and assign specific users or groups within your organization to specific projects across multiple systems. And that's about it for the very high overview of projects. Now, here I've got the configuration list from our documentation open. There's a number of configuration keys that apply to projects, things like what compression algorithm do you want to use, refresh frequency for images, that kind of stuff. On top of those features I mentioned that are here that you can configure also through those config keys, worth noting that features are locked as soon as you create something in the project, so you should really set those before creating any instances, otherwise you will need to delete everything to be able to set those. Then we've got the limits. So as mentioned, you can set limits on things like CPU, disk, memory, networks, processes, or even on the general number of containers or virtual machines you're allowed to have. The one thing to mention there is that those are allocation limits. They are not usage limits. So that means that if you give 5 gigs to 5 containers, you're going to have consumed 25 gigs, whether they write anything to those 5 gigs or not. That makes enforcement much easier on the LXD side because we can just look at the database and calculate all the quotas and enforce them that way. But it means you will need to effectively give much higher quotas than the actual amount of resources that you expect the users to see. Often in larger environments, what you will probably do is put some limits, let the users consume that, and then you're going to use the metrics API that LXD offers to look at the actual consumption, and you might then do billing or resource planning based on those numbers instead. All right, then you've got restrictions. Restrictions, there's a main knob called restricted that if turned on will effectively turn on all the restrictions, and you can then soften those restrictions by allowing specific features. That includes things like enabling backups, which are pretty CPU intensive on the host, so they're off by default, but you can turn them on for specific projects. Or allowing things like nesting, low-level container configuration, even running privileged containers, using some amount of interception. There's some knobs there to control exactly what. Things like accessing disks, and if so, what paths can be accessed for disk pass-through, whether you want GPU, InfiniBand, specific network access, PCI device, all of that can be restricted. And we've been increasing kind of the granularity on a lot of those as time passes. So that's pretty much it for the high-level overview of LXD projects. So now let's go look at the system that I've got around that can run some projects on there. So this is LXD 5.6. It's running with ZFS setup. It's also listening on the network, which just makes it easier for the demo here. And if we look out of the box, we don't have any projects. The only one that's listed there is the default project, and that contains everything. So if we go look at what it has right now, we can see it's got the default profile in it, it's got the default network in it, and it's got an image already cached in there. So if I go launch, say, a 2204 container, there we go. This is running inside of the default project on the system. Now, one thing you can do if you want to play with projects in a very easy way is to use our multi-user LXD daemon, which is part of the LXD snap. So you can just do snap set LXD daemon.users.group, I think. I'm just gonna go check the documentation real quick. Yeah, daemon user group. So you do snap set LXD daemon user group, and let's set it to groups. What that means is that anyone who's in the groups group actually it's users, I meant. That makes more sense. Okay, and then you need to reload LXD. Okay, so what that means is that anyone who is in the users group will now be allowed access to LXD, but a restricted kind of access that's gonna be able to run instances, but not take over the entire system. To demo that, let's create two users. I'm gonna create a user called foo. Okay, and foo, nothing special to that one. Then create a user called bar, and bar we're gonna put in the users group. Okay, so if I go back on the system, okay, and I go look at foo, and foo tries to talk to LXD, nothing happens, permission denied. That makes sense, that user is not in the users group and it's not in the LXD group. Now if I go try with bar instead, bar gets presented with an empty list, which you might have noticed does not line up with what we see in the root user. That's because LXD has automatically generated a new project for that user, which we can see here as user 1002. And if we go look at the configuration for it, this is a restricted project. It has all the features enabled except for networks, and restrictions are set in place to allow for container nesting, allow for disks, but only for anything under /home/bar. It does have access to GPUs and has access to the UID and GID of that specific user. But that, for example, will bar access to any Unix devices or USB devices or anything that could be used to escalate to full root access on the system. But to that user, it's perfectly functional. They can now create their own container. And here we go. It just works out of the box, no need to configure anything. And as root here, so I still see my own. You notice we actually have two containers called U1 in two different projects. They've got different IP addresses. As the administrator who can see everything, you can actually run all projects. And then you see now default project U1, user 1002 U1. That also shows you that they are properly insulated. You can actually use the exact same resource name in both and not have any conflicts. Sorry. Okay, so with that in place, now let's look at maybe a more traditional project. So not one that's automatically generated by LXD for you. So I'm going to be creating a new project called demo. And if we look at that demo project, again, all the features are enabled out of the box except for networks. To get you an idea, so if you can switch over to a project using project switch. So switch over to demo. If you look at the instance list, it is empty. If you look at the image list, it is empty. Now, one feature that you can turn on or off are the images. So if I do project set demo features images false, and then I list the images, now we see an image, and then you set it back to true, and it's gone. So what happens is that if a feature is disabled, then you inherit from the main project, the default project in this case. Now, one thing that happens when you manually create a project is that, well, you have nothing in it. So it does come with a default profile, but the default profile lacks any kind of configuration. There's no devices, there's nothing in there. If I try to actually launch yet another U1 container, it's gonna fail. And you need to fix that by either manually adding the config, so in this case, the root device and the network device, or one thing you can do is go and peek in the default project. So that's the one in the default project, and you can actually dump that back into yours. At which point, if I look at my own default profile, it's now matching the one in the default project. And I can run yet another U1. There you go. Now we've got 3 U1s, one in each project. Remotely, if you want to access that project, what you can do is use trust add. So LXD config trust add name, let's call it Dakar, which is the name of that desktop system. And then do projects that it's allowed demo, and we want it to be restricted credential. So you get that token, and then you can do remote add demo project, that token, add it. And now if I list demo project, we can see U1, and if we compare, we can see it's the same U1, it's the same IP address. The other thing here I can do is if I do project list, we can see that with those credentials, I can only see a single project, which is the demo one. And that also means I don't get to change any settings on the project. I'm just not allowed because I'm just a simple user of that project. I can create stuff in it. I can create, let's say, a U2 container, demo project U2, that I can create, but I don't get to go and change the settings of the project itself. Only the administrators do get to do that. And so to play a bit with restrictions, like right now I get to see absolutely everything. Let's just change that a bit. So again, as an administrator, well, let's try to do it as a normal user just to show that this doesn't work. So you do demo project, and the name of the project in this case is demo, and we want restricted to be true, not authorized. So that's what you get, because like that remote user is restricted and it's just tied to that project. It's just a simple operator, not allowed to configure anything. Whereas the root shell here is fully and is a full admin, so it can change that. So if we do restricted true, okay, oops, now this is set. One thing that we can try pretty easily that's blocked for very good reasons would be privileged containers. So if we try to create one of those, it is failing with privileged containers are forbidden. Same thing if I try to do nesting. This is disabled. We can allow that one. So you can look at the config keys here, containers, nesting, true, allow. Okay, now it's allowed, now you can create it. Similarly with networks, so right now if I list the networks in there, I see I see all LXD managed networks once the restrictions are enabled. So I used to be able to see all of those. Now they're gone because with restrictions you don't get to use arbitrary networks, you only get to use networks that are managed by LXD. Now if I create foo br0 in the default project, now we've got 2 networks here that I could use. If I want to change that, we can do that with a restricted keys to networks access, and then we restrict it just to LXD br0. And there you go. So it's really quite flexible. As mentioned, there's a lot of configuration keys that can be used under restricted to really change all of that kind of behavior. The other thing I mentioned are the resource limits. I'm just going to show the most basic one, which would be instances. Let's do 3. So I'm currently running 3. If I'm trying to run 4, reach maximum number of instances in this project. So that's pretty straightforward. I could actually change things a bit and do containers 3, instances 5. So this still fails, but now if I make this a virtual machine instead, this is not a container, therefore will not count towards that particular part of the quota and will work. Just taking a little while to create. There we go. So that's pretty good look at both, again, if we show the full config, at both the features that we went through real quick, the limits. In this case, I just have containers and instances. I didn't put any limit on disk or CPU or that kind of stuff. And some of the basic restrictions, with some of the more advanced restrictions being used in this case for that automatically generated one that has a number of extra restrictions in place here. And that's really what LXD projects get you. It is a pretty flexible feature. I can also show you that in the trust store, that token we generated for user Dakara is here, and you can go look at trust show, and it does show you restricted and what projects it has access to. You can change that live, so you can totally go here, and if I do project list on demo project, right now I see just the one. If I edit, I can turn off the restriction entirely, at which point that will make that user an admin and they get to see absolutely everything. Or I can turn the restriction back on and say that, well, actually I'm fine with it also using the default project. I just don't want that user to access the user project. And there we go. So that's really quite flexible. It's a great tool for shared environments, whether it's a single system or even a cluster. You can easily create a number of projects on that and then allocate credentials to different users that can play in their own separate sandbox. Combined with a lot of the extra restrictions that we have, you can really make something pretty tight and working very well for multi-user environments. And that's it for a look at LXD projects. I hope this was useful. Again, the documentation really goes through every single of the config keys. I was not going to go through every one of the restrictions you can apply, but there's really quite a lot there to use to really fit your environment and fit also your amount of trust into specific users. There are definitely some of those that are effectively handing out like full root access to the system. Like if you're doing fully allow disks, that's a pretty easy way to get access to anything you want on the host system. Same thing if you allow for privileged containers. Same thing if you allow for low-level configuration of containers. But a lot of the others can actually be quite safe. Like in some environments, accessing USB device is fine. Not always. Like, they might be able to use your keyboard. That might be a problem. There's a lot of options, and we're also adding more and more granularity as we go. So yeah, hopefully a bunch of you will be interested in taking a look at projects and how you might be able to run multi-user environments, or even to just split your own workloads across multiple projects on your own system. If you've got any questions about it, feel free to leave them below or on the community forum, and I'll see you in the next video. Bye.